We've covered the physics implementation in the previous video. For this one, we will be making a spawning system. If you haven't seen the last video, please follow the link and come back. Alright, let's organize a bit before we jump right in. First, let's select these 4 nodes and Ctrl-G to group them. Additionally, I'm going to drag out group inputs from store named attribute values to make them into arguments. Rename this one to shell radius. This one to initial mass. Initial velocity. Lastly, to initial position. Step outside of the node group and rename it to init shell. Values will be carried over, so it should behave as before. If not, please check the connections and value settings. There are 2 operations for burst and spawning system. Delete the old shell and spawn new stars at the same time. Okay, let's start by deleting the shell. Insert a delete geometry right before the simulation output. Next, to make a conditional, we'll want to add new attributes, so let's move to init shell. Add new store named attribute and call this tShellSpawn. Add another and call this one tShellBurst. So each point will keep track of when it was born and when to kill itself. For spawn, let's pull out a group input and make it into an argument. Call it shell spawn timing. Duplicate shell spawn timing and create another argument, shell lifetime, to plug into burst. The burst timing is basically lifetime added to spawn timing. With these new attributes created, let's insert 4 seconds into shell lifetime. Next, drag out a greater than from selection of delete geometry. And make a conditional so point is deleted when the scene time exceeds tShellBurst. With animation, we can confirm that point is deleted at 97-second mark. Next is the star spawning. Let's create some space here and pull out an instance on points from geometry socket. We can instance any shape, but let's go with icosphere for now. Convert vertices to points by using mesh to points. Without conditional, this will keep on spawning. So I'm going to use the same condition as deleting conditionals and plug it into selection. Next, let's realize instance. Then duplicate the init shell node group and start initializing these parameters. As for parameters of the stars, set 0.01 meter for shell radius, 0.005 kilogram for initial mass, revert velocity and position to 0 for now, and set the shell lifetime to 1 second. For the spawn timing, we will use the current frame time of scene time. Next, for initial position, we will use the named attribute pause. This might need some explanation. I purposely did not use the position node up till now. The way this works is that the named attribute pause is inherited attribute from the parent shell. The one that bursts right here. If I were to use a position node instead, this takes the value of instanced object, which is the icosphere. Since the initial position I want to use here is that of the parent, named attribute pause is used. It is confusing, but just know these two position values are different at this point. Next is the initial speed. First, we will have to consider the velocity of the shell before burst. So let's add the named attribute vel. Next, we'll add the position node scaled by a constant value to this velocity. To explain this, we need to understand initial velocity becomes larger when star is set further away from the center of the shell. Just to illustrate, when star is set closer to center, there's going to be force from both sides canceling itself. If star is set closer to perimeter, there's only force acting from one side, thus travels faster. I'm cutting corners by just using position here, but consider that distance from object origin, which is a position node, becomes proportional to velocity. Okay, let's input 150 into the scale value and make some adjustments. Next, add a join geometry nodes and get these points to do some physics as well. Before running the animation, there's a chance that a whole bunch of points get spawned and crashes Blender. So let's save and set the end frame to around 150 frames. Alright, let's run the animation. Awesome. It is bursting and spawning points. The current setting is causing points to spawn infinitely, but we will deal with it later. I'm going to group up the initial velocity calculation. Then rename the scale input to initial speed. Let's call the node group calc init vel. Alright, reorganizing. Okay, we want to make sure that we are not endlessly spawning points. First, let's create an attribute to determine if the point should spawn or not. We want points to spawn if it is a shell and not if it is a star. Within init shell, let's add a store named attribute, change the type to boolean, and call it bShell. Make this into an argument and call it isShell. For the first init shell, since we want it to burst, we'll set this to true. For the one in simulation zone, we can set this to false. Next, add a conditional for instance on points to make sure it is a shell. After the greater than node, add an AND node and check bShell is true. I'll group these up and call it judge burst. Let's reorganize and run animation. If the conditional was made correctly, after the first burst, points should not spawn additional children. Okay, that is it for this video, so let's summarize. Today, we made a burst and spawning logic. Part that deletes the points, and the part that spawns new points. With that, we've added 3 new attributes in init shell. Next, conditional to perform instance on points. Initial velocity calculation. For the next video, we'll replicate combustion to make the points behave closer to actual fireworks. Thank you for watching, and see you next time.